This is recording 1A in our series on solving quadratic equations by completing the square for Unit 4, Chapter 4 of Mathematics 2200. We'll focus on the square root property and how it can be applied to solve quadratic equations. The square root property says, if a squared equals b, then a equals plus or minus the square root of b. Another way of thinking about it is, if you have an expression squared equal to a number, I'll abbreviate that word with NUM, then the expression is equal to plus or minus the square root of the number. Let's apply this to the first example. This question is really saying, what number squared equals 9? Well, right off the bat, you're probably thinking 3. 3 squared will give you 9, and that's true. So we have x equals the square root of 9, and that will give you x equals positive 3. However, what about the negative 3? Negative 3 squared would also give us 9. So we really should consider the negative case as well. Let's check the answers. I know it's a little bit obvious here, but let's do it because it'll lead us on into the next phase. 3 squared, so we're checking x equals 3. 3 squared is equal to 9. 9 equals 9. Yes, indeed, it's true. What about negative 3? Negative 3 all squared equals 9. 9 equals 9. Don't make the mistake, if you do this on a calculator, of leaving the negative sign outside of the brackets. For example, on a calculator, this will be true. We're squaring the negative part as well. So be very careful to include the negative sign as part of the brackets there. So just put that there as a note for your recording. I won't put that in the official notes that are posted. In this next one, we have x minus 1 squared minus 49 equals 0. So what we want is to have this in the form expression squared equals the number. Don't quite have it in that form yet, so we're going to isolate the squared part. So we've got x minus 1 squared equals 49 when I add 49 to both sides of the equation. Next, I can take the square root of 49, plus or minus the square root of that. So that gives me x minus 1 equals plus or minus 7. So that gives me further two cases. Case 1. X minus 1 equals positive 7. That gives me x equals 1 plus 7, which is 8. Case 2. X minus 1 equals negative 7. That gives me x equals 1 subtract 7, which is negative 6. Let's see why both of those answers will make sense. So we'll check. I'll check x equals 8 first. We have 8 minus 1 squared minus 49 equals 0. Checking in the original equation. That gives me 7 squared in that bracket, which is 49. So 49 minus 49 does indeed equal 0. So we check now x equals negative 6. I'll have negative 6 minus 1 squared minus 49 equals 0. That gives me negative 7 squared minus 49 equals 0. The negative 7 squared is indeed 49. So obviously that one is good as well. So both are good. In this third one, we have x plus 2/9 squared, and I see that should have been a c there, not a b. X plus 2/9 squared equals 27 over 81. So we'll take plus or minus the square root of 27 over 81. Now, we got a couple of things going on here. One of them is that we need to take the square root of 27 and the square root of 81 in that fraction there. So the square root of 81 is 9. What are we going to do with that square root of 27? Well, from Math 1201, you would hopefully recall that the square root of 27 can be thought of as the square root of 9, which is a perfect square root, and the square root of 3. So the square root of 9 is 3, so we have 3 times the square root of 3. So we really have plus or minus the square root of 3 times the square root of 3 over 9. And that gives us, when we rearrange here and solve for x, x equals negative 2/9 plus or minus 3 root 3 over 9. So because we have the plus or minus, we really have two cases, negative 2 plus 3 root 3 all over 9, because they have the common denominator already, and negative 2 minus 3 root 3 all over 9, again because we have the common denominator already. In this final example, we're asked to find the zeros or the x-intercepts of the function. Recall from earlier in the chapter, section 4.1, the zeros of the function are equal to the roots of the equation, so we put 0 in for the y. Oh, little typo there. We rearrange, so we bring that 6 over to the left side here. Then we divide both sides by the 2, so that we have 3 equals x minus 4 squared. From there, we will now have plus or minus the square root of 3 equals x minus 4, and so we now have 4 plus or minus root 3 equals x. And if desired, we can write these as two separate cases as before. To summarize, the square root property states if a squared equals b, then a equals plus or minus root b, and the square root property can be applied to solve quadratic equations in standard form and to find the x-intercepts of quadratic functions in vertex form.